Hi, this is Mr. Cook. This is for lesson 3.3, finding slope. In example 1 here, we're asked to find the slope of each line. Now slope, if you remember, is rise over run. This should be a bit of review for you. Now when you calculate rise and run, you have to go from known points on the line. So that means you should use points that are already graphed there for you. So for example here in A, we're given point O and point S. So we want to calculate the rise and the run from O to S. Now when we do that, if I go up, that's in the positive direction. If I go down, that's negative. Now when I count run, if I go right, that's positive, and if I go left, that's negative. Now you have to be careful. When you graph a point, you graph horizontally first, so you run before you jump. When you do slope, it's the reverse of that. So you have to calculate your vertical distance first and then your horizontal distance. So this is really simple when you have a graph. I'm going to start at O, and I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So I have a rise of positive 8. And then I'm going to go left 1, 2. So that's a run of negative 2. Negative because I went left. So my slope here for A is negative 2 over 8. Now that fraction can be reduced because both numbers are even. So I can divide them both by 2, and that will simplify to negative 1 over 4. So that's for A. Now, for number B, letter B, I want to calculate the slope from Q to P. Now this is a vertical line right on the y-axis. If I count from Q to P, use the same method that I just used in example A, I can rise 1, 2, 3, 4, 5, 6, 7. So I had a rise of 7. Now I don't have to go left or right at all, so my run will be 0. Now if you take your calculator and type in 7 divided by 0, your calculator will give you one of two answers. It'll give you undefined as an answer, or it'll say error. And that's because we can't divide by 0. So whenever you have a 0 in the bottom of a fraction, your answer is going to be undefined. So every vertical line is going to have a run of 0. So all vertical lines have a slope that is undefined. Now on to letter C. This line rises from left to right. So when we count, we're going to count from G to F. So I'm going to rise first. So starting at G, I go up 1, 2, 3, 4, 5, 6, 7. And I have a run of 1, 2, 3, 4, 5, 6, 7, 8 in the positive direction. So my slope is 7 over 8. That fraction cannot be reduced, so 7/8 is my slope. Now notice In A, my line rose from left to right, or right to left rather, or it fell from left to right. In C, my line rose from left to right. So if the line falls from left to right, it's a negative slope. If the line rises from left to right, it's a positive slope. Now let's look at D. In question D here, we have line XY, and there is no rise. So if I want to travel from X to Y following the grid lines, I rise 0, and then I have a run of 1, 2, 3, 4, 5, 6, 7, 8 in the positive direction. Now if you put 0 divided by 8 in your calculator, you will get 0 for an answer. Now all horizontal lines are going to have a slope of 0. So all vertical lines have an undefined slope. All horizontal lines have a slope of 0. In this example from lesson 3.3, we're asked to create a graph of a situation in the context of recreation. In 2000, the annual sales for one manufacturer of camping equipment was $48.9 million. In 2005, the total sales were $85.9 million. If sales increase at the same rate, what will be the total sales in 2015? Okay, when you create a graph, you should always put time on the bottom. Now, if this is a graph over time, we should use a line graph and not a bar graph. Bar graphs are used for comparing things. Line graphs are used for showing changes over time. So we're going to use a line graph here. And this starts at 2000. So my first at the bottom here, this is going to be time or years, starting at 2000. Now I don't need to put a mark for every year. I only need to put a mark for, let's say, every 5 years, since this goes from 2000 to 2005, and then I want to find out what 2015 is. Those are all multiples of 5, so we'll count by 5s. So there's 2000. Here's 2005. 2010. And then finally 2015. Now for my vertical axis, I want to use dollars, or sales rather, and that's going to be in millions of dollars. Now to simplify our graph, I don't need to start it at 0. I can start at my lowest amount, or amount near that, let's say 45 million at the bottom. And I have to get at least to 85 million. It increased almost double in the first 5 years, so I probably want to go as high as 3 times the original amount. So let's count this by tens. So 45 million, and there's 55 million, 65, 75, 85, 90 million. at the top. Okay. My first piece of data was in the year 2000, and I had 48.9 million, or just below 50 million. So it'll be somewhere between the 45 and the 55. So I'm going to put a dot, and let's use a blue dot here, just somewhere in the middle of 45 and 55. So that would represent 48.9 million in 2000. In 2005, we were at 85.9 million, so just above 85. Okay. So if I draw a straight line from my first dot to my second dot, that shows the change in sales from 2000 to 2005. I have to get all the way to 2015. So I have to go another 10 years beyond 2005. Now, if sales continue at the same rate, what we want to calculate then, when we talk about rate, so we want to calculate the slope of that line. So for rate of change, that's the same thing as the slope, which, if you remember, is rise over run. So the rise and run of this line, I go up, again, I started here at $48.9 million, and I went up to $85.9 million. And then that was my run, would be a change of 5 years. So to find the rise, what I need to do is subtract 48.9 million from 85.9 million. So I'm going to do that math problem over here. 85.9 million minus 48.9 million. Line up your decimal points. 9 minus 9 is 0. I have to borrow from my 8. So that would be 7. 15 minus 8 is 7. And then 7 minus 4 is 3. So I had a change of 37 million, or a rise of 37 million over that period of time. So my slope will be 37 over 5. That's my rate of change. $37 million increase over 5 years. So what would that increase be over 15 years? Well, what you have to do and why did I say 15 years? Because this distance here is 15. So ask yourself, what would you have to multiply? This is just an equivalent fraction. What would I have to multiply 5 by here to change it to 15? Well, hopefully you know your multiplication facts, and you know that 5 times 3 is equal to 15. So here, all I have to do in the top then is multiply that by 3. So 37 times 3 would be 111. So I would end up at $111 million, or $111 million increase over 15 years. So I have to, so this is how much I would increase. I have to add that to my starting amount. So I have to add 111 to 48.9. Now again, line up your decimal points. There is no decimal point in 111, so I have to put one in there and add a 0. So I can line it up with my 48.9. And I'm going to add that. So I'm going to end up in 2015. I'm going to end up with $159.9 million. In 2015. If I had made my graph a little taller, I would see that this line would continue at the same slope, moving up and off the page. This is clearly a successful business. Let's move on to example 3. In example 3 here, we have to determine if FG and line HG are parallel, perpendicular, or neither. So we're going to have to graph. Now when you're graphing things, you have to run before you jump. And make sure that you keep that straight, because when you're calculating slope of these lines, you have to do rise over run, which is the reverse of graphing a point. But first I'm going to graph these. F is at -1, 3. So I start at the origin when I graph a point, and I go to the right 1 and then down 3. And I'm going to put my point right there. So that's point F. Point G is at -2, -1. So again, starting at the origin, I go left 2, down 1, and that's G. And then I simply connect the dots. HJ is 5, 0. Again, this is a line, by the way, not a line segment, so I want to actually continue this through those points, because I want to make sure my lines, if they do intersect, I want to see where they intersect. Point H is at 5, 0. So again, starting at the origin, go right 5 and up 0. So that's right there on the x-axis, and that's point H. And J is at 6, 3. So I go over to 6 on the x-axis and then up 3. Here's J. Now you see, if I just connected the dots, instead of drawing the line all the way through, these lines wouldn't intersect. So I want to continue this all the way through. Okay, now I'm doing this on the iPad, so I really can't tell if I've drawn my lines straight or not. Clearly I did not draw them perfectly straight. So I can't tell right now just by looking if these two lines are perpendicular. Clearly they're not parallel. So I have to determine whether they're perpendicular or not. And to do that, I'm going to use slope. The slope from F to G would be up 2, then left 3. So my slope here is 2 over -3. my slope from J to H is up 3, right 1. So that has a slope of 3 over 1. Okay, now if I look at these two fractions, 2, negative 3, and 3, 1, I can tell that these two lines are neither parallel nor perpendicular. Parallel lines have the same slope. Perpendicular lines, the upside down T is the symbol for perpendicular, have a slope that are opposite reciprocals. Now, opposite reciprocals simply means opposite. One's negative, one's positive. So right now I'm looking at my two fractions, negative 2/3 and 3 over 1. They're opposites because this first one's negative and the second one is positive. So they are opposites. That's good. But they're not reciprocals. Reciprocals means that one fraction is the same numbers but upside down. So if this number here was a 2 instead of a 1, it would be the reciprocal of 2/3. I'd have 3 over 2. But I don't have that situation. They're opposites, but they're not reciprocals. So in this case, my answer is they are neither parallel nor perpendicular.